Good afternoon, everyone. I'm Chris Levan with Shadler Yesco. Welcome to today's Webinar Wednesday on Siemens electric vehicle charging solutions. Your cameras and microphones are turned off to keep things running smoothly. Please post any questions in the chat, and we will answer them at the end of the presentation. This training will be recorded and posted online for future viewing. And I will now turn things over to John Politis, who will be our host. Go ahead, take it, John.
Thank you, Chris. Good afternoon, everybody. As Chris mentioned, this is our first Wednesday series webinar, and welcome to the Siemens EV charging solution. So we're going to go ahead and get started. And if you noticed in the chat section, the copy of the presentation is there, as well as my contact information. So please use that and keep that for any future discussions. And we'll have a Q&A session at the end. So if you want to put any of your questions in the chat, we'll manage those at the end of the presentation. So let's go ahead and get started with electric vehicle charging solutions. So what we wanted to show and the way we position electric vehicle chargers is it's basically through this one-line diagram. And this follows our energy savings and power solutions sales initiative that we have here at Shadler Yesco. So if you look to the bottom right, you can see electric vehicle charging stations as one of the solutions. Obviously, there are everybody has an electric meter as far as different power consumers, either being residential, commercial, industrial. And then within those power solutions, we have different things going on, especially with looking behind the meter or in front of the meter. So behind the meter, the meter obviously does kilowatt demand, kilowatt hour usage, and things of that nature. But we have a lot of different things that we can do from a power management standpoint, or offsetting electricity or power, or doing energy efficiency, with lighting or data centers or process control. So we look at the electric vehicle charging stations as a power management device, and basically that's how that fits into this big picture. When we specifically talk about Siemens, Siemens has what they call a plug-to-grid type scenario, if you will. So basically what they focus on is not only the upfront design build side of things, because when you look at these chargers, regardless if it's simple one install or multiple install, with fleets, or even if you get into a lot of the other high power electric vehicle charging solutions, you're going to have to consider the power distribution requirements needed for the end device, which is the EV chargers. So if we move from left to right, there's design build capabilities, there's the actual chargers themselves, and then we look at trying to maybe integrate the power distribution or the gear equipment. And a lot of times that may involve getting coordinated with the utilities. And then from there, we look at cloud services if you decide that you want to do some billing or load management, and then also look at some project financing and so forth. So that's their pretty much start to finish the way they look at electric vehicle charging solutions. So they call their whole group Siemens e-mobility. That's their whole group is dedicated for electric vehicle AC and DC charging. They're all based out of Atlanta, Georgia, with the parent company out of Germany. And then the U.S. factory footprint for manufacturing for the AC side is some international and U.S. plants. The DC charging comes out of the North Carolina, Georgia, Tennessee, and then all the gear products come out of North Carolina, South Carolina, and Texas. So again, it is a combined group effort there. So let's look at the electric vehicles and some of the key factors that we have that's driving this business. So one of the things we look at is what transportation sectors are into electric vehicles themselves, and it's pretty much everybody, from the automotive market to delivery, work vehicles, school buses, semi trucks. I think most folks see the commercials and follow the business plans from Ford and GM and some of those folks. So now I think everybody's into looking at providing some sort of electric vehicle. Some other factors that we see that are really driving this business now. For us, we've been selling electric vehicle charging stations for about 12 years. I personally been in and out of it for about this is the fourth time, if you will, that I've been in and out of EV chargers. But I could safely say that I think it's here to stay. And these are the 5 reasons why it's going to be here to stay. It is a lower operating cost. As you look at gas, hitting $3, $4, $5 a gallon, electricity is cheaper than gas. So right out of the gate, you've got a lower operating cost. Some of the small, mid-sized electric vehicles are now affordable. You start getting into the larger size in the trucks, you may argue that point, but they are becoming more affordable compared to the 10 years ago. Increased environmental concerns, the tailpipe emissions. That is a big thing with the greenhouse gases. Whatever your views are on the environmental side of things. But there is a goal from the government to try to reduce tailpipe emissions. Incentives. So there are many incentives out there, and we can share these links with you on how to get engaged or engage your clients with these incentives. One of the most popular one right now for EV charging stations is the Pennsylvania Department of Environmental Protection has a PA Path Forward rebate or grant that's available. That will give you up to $4,000 per station if you decide to put that out on the public network. And it tiers down if you want to use it for workplace or more private use. And number 5 basically is saying that the charger infrastructure out there is basically needs to be worked on. There isn't a lot of charging stations out there. A lot of folks are starting to plan for this, design for this as far as commercial and industrial facilities. So that allows great opportunity for contractors to provide this as a turnkey solution. So again, these are the most 5 common factors out there that are really driving this business sector. So one of the things that we really explain or try to position is the level of EV charging that you may have or want to get into. And a lot of times this leads into how you want to operate or what your sequence of operation looks like. Um, so right out, if you look at the chart or follow through from left to right, this chart is also available when we hand this presentation out. On the bottom is a link to our Shadler website and our EV charging solutions. It's an info sheet, so this charger is available for your reference. So if you look at level 1, it operates 120 volts, typical standard AC outlet. That comes with all the electric vehicles that are purchased. Usually they have it sitting in the trunk. It's a loose device. You plug it in a 120-volt outlet, and the big part of that is the focus here is the estimated charge time down on fourth from the bottom. So as you can see, to go from a full charge, almost 10, 20% to 100%, it's going to take you up to 3 or 4 days, which will probably give you about anywhere from 250 miles to 300 miles. So a lot of folks they basically have to plan their trip, plan their usage on where they're going and if that is suitable for charging. The sweet spot that we're seeing and getting a lot of activity on is level 2. Level 2 requires a 208 or 240-volt source. It's usually a 2-pole, either 30, 40, or 50 amp breaker, sometimes 60 amp breaker, depending on the size of the unit. But what the focus is again, the estimated charge time, anywhere from 4 to 14 hours to get a full charge. So the whole idea here is if you want to charge in days, hours, or minutes, and it's an important thing to talk to the end user, talk to the clients about this the charging time. The next and last is level 3 DC fast charger. Once you get into those bigger units, and I'll explain and show you the difference between level 2 and level 3 in a minute. But that can actually get you down into minutes, sometimes 15 to 30 minutes for a full charge. What it gets down to is economics. So a charger, level 2 charger, is anywhere under $3,000 starting point. Level 3 starts at about $95,000. So a lot of times that might dictate, do I want level 2 or level 3? So let's look at both of these. As far as the AC and DC, or level 2 and level 3s. So again, we take a direct source, 208, 240, into an AC charger level 2, and then that will connect up to the car. And basically in the car, there's an inverter that inverts that back from AC to DC to charge the lithium battery. So it's a smaller package. It's less cost compared to the DC level 3. And the big difference there is that the inverter is actually in the charger itself. So you bring in 480 volt three-phase source through an inverter that's inside the charger, and it's going to produce up to 1,000 volts out the coupler and directly connect up to the battery of the car. So again, that's the biggest difference between the AC level 2 versus DC level 3. And again, to note, Siemens offers both products, and I'll talk about the product offering here in a minute. Now, as we look at the different plug types, so there's some different terminology here. For AC, it's a J1772. This is the regulation and standards is by the automotive industry in North America. So all the AC EV chargers from Siemens and a lot of the other manufacturers have a standard J1772. All the vehicles in North America, except Tesla, can accept the J1772 connector. Tesla, as it's shown there on the right, has its own unique connector. And normally, when you buy a Tesla vehicle, they'll have an adapter or some sort of pigtail to take you from a Tesla over to J1772. As you move into DC level 3, they have what they call a CCSI. It's a common coupler system type connector. The top part of that connector is identical to the J1772, but what they do is add 2 pins on the bottom for a plus minus DC connection coming out. So that's a thing to consider when you're looking at the different charging types. Again, let's focus back on charging times. So up on top is our AC charger, connected up to a 75 kW battery. Again, these are lithium batteries that typically sit underneath the seats of the cars. But as you go down through the current rating of chargers, 16 amp all the way down through up to 48. Some chargers are actually getting up into 60 amp units. Siemens will have a 60 amp unit coming out here in April. So as you can see to the right are the charge times, the hours. So again, a 48 amp unit, that 75 kW battery will give you about under 5 hours for a full charge. And by hour, as far as miles, you can get an idea there. It gives you about 36 miles of range per hour if you want to look at it that way. So again, the bottom line there is you need to plan your trip or plan your usage of your electric vehicle. In comparison, you have the DC version, or level 3, connected up to that same battery. You can see what happens as you provide a 50 kW for 1 hour and 20 minutes versus a bigger unit, 175 at 23 minutes. But again, you need to consider your power distribution or your service coming into both of the AC and DC level 2s and 3s. So let's look at a pickup truck. You can see pickup trucks and semis and delivery trucks, they get into larger batteries. They can actually go out to about 200 kWh, and you can see what happens to the charge time. So that same 48 amp charger AC, instead of 5 hours, now it's about 6 or 7 hours to do a full charge on the truck. But keep in mind the cost of these are about $100,000 plus on a new electric vehicle or electric vehicle truck. So let's drill into the products. Again, this is Siemens e-mobility product line. So we start from the left to the go right. So left is our AC level 2 chargers. They have a 9.6 kW, which is a 40 amp unit, and 11.5, which is a 48 amp unit. And they have various different communications from Wi-Fi to Ethernet to cellular. You can also do Modbus to building automation. You can access it with an RFID card if that's the way you want to start your charging session. Or normally out of the box, you can just power up the unit and go ahead and do a full charge. And basically, you're going to do a free charging mode for any electric vehicle. But again, the power source is 240 single phase, 60 amps and under for the breaker. And as you move up into the DC fast charger, even in the DC heavy duty, and even taking it further in transportation or port authority, we get into bus chargers. You need a 480 volt three-phase supply, and that depending on the size unit, you can get yourself into a 300 amp, 600 amp breaker for that proper protection. So again, the point is you need to really consider the power infrastructure or power design coming into these AC or DC chargers. And all of them have some sort of cloud service. So you can decide if you want to do billing, if you want to do any load control, any trending, any remote monitoring. They all have the ability to do some sort of cloud services, which is an option to the units. Siemens, as a lot of folks know, they are their main bread and butter, if you will, is the power infrastructure. Your load centers, panel boards, your gear, transformer equipment. So it's a nice fit when you have an end device like a charger, where they can actually get into helping out with power design, and we can offer the power distribution equipment to go along with the charger. So it's definitely a nice package. They have a thing what they call a make ready, um, which is basically it allows you to get into the gear package that's suited to the types of chargers that you're using, either AC or DC. So focus back on the AC side, that level twos, that's where a lot of our demand, or a lot of our quoting, a lot of our installs is around. We do occasionally get into some DC, but again, because of price, a lot of folks are just settling in on the level 2 AC chargers. So you can decide if you want to put your charger in the garage, at home for residential, at the workplace. You can use it for employee convenience, if you will. And then, as I mentioned, we talked about the connection, the billing piece of it, and the communications. And there's an app that goes along with the chargers. There's the free app that can get downloaded to your phones, and that can be used for configuration, commissioning, and then also monitoring after the units are up and running. This is an example of a make-ready system where you have, maybe some coordination with the utility company. You come into a make-ready panel. So in the picture in the background here is the make-ready gear package supporting these two large DC fast chargers. So these are normally outdoor rated, have a utility transformer coming in, and then you have the gear equipment and protection equipment serving as service to these DC chargers. So you can have a combination on the bottom here is a combination level twos setup. And then coming over here for a 480 volt supply, which is supplying a level 3. We find some dealerships, through some of the corporate GM and Ford and Nissan and Honda. They have various different requirements where it's a mix of level 2s and level 3s. So we're always discussing the charger side of things, but mainly also part of the big picture is the panel board or the transformer or the gear setup. Very common discussion that we have with them. So let's look at scope of work. Just to give you a general idea what the typical scope of work looks like for a EV charger installation. So National Electric Code has section Article 625, which is labeled Electric Vehicle Charging System. So based on that section, inspectors and if you're doing any install or design build opportunities, that's the National Electric Code that we follow. And then that goes along with the local authority having jurisdiction, whatever rules that they may have in addition. So scope of work 1 through 7. On the electrical side, we have power wiring per the charger level and specs. We talked about the level 3s and level 2s, and as far as their requirements for supply. Then you'll have a low voltage or an IT side of things. We'll always recommend Ethernet over Wi-Fi, just because of the signal strengths that you may run into problems coming from a building. So we'll always look at Ethernet hardwire connection. Or in some cases, if you can't jump on an existing LAN system, some federal and state, typically you have different fire rules, if you will. We'll need to look at cellular connection versus Ethernet in those cases. Then there's system commissioning, some setup things, sequence of operation needs to be looked at. Um, then the big part of the scope of work is the numbers 4 through 7. You need to think about trenching. Where's your power source from point A to point B, and versus where you're going to mount the actual chargers, either a wall mount or post mount. You got to think about the curbs, the sidewalks, and the parking lot repairs. Then there's some protections around for the chargers themselves. Safety curbs, steel and concrete bollards. We have a little picture here that shows some of this as far as the typical installation. And then the last piece of it, the owner may decide to identify that this parking spot is dedicated for electric vehicles only. So you're going to have some signage. You may decide to paint it in green as far as the actual parking spots themselves. The last note there, always plan for the future. I guess it's really an unknown right now how the electric vehicles is going to be coming into our different areas here in Pennsylvania. We get a lot of calls. The conversation starts off with 2 chargers, and by the end of the conversation, we're talking planning for 8 or 10. So it's always good, especially on the power design or the service equipment, to size for future, size for the additional 10 or 12 that might be coming in as a phased approach. Because you never know, they'll put 2 in and probably get another call in hopefully 10 months, 12 months, then they'll be looking to add more chargers to that to their system. So when we look at electrical vehicle charging turnkey solutions, you obviously as a material supplier and the support of that, the electric vehicle chargers, we're a big part of that. A lot of times we're quarterbacking, the different team members here, but we have the owner in the middle. We may have design engineers, utility companies, incentive admin, electrical contractors for the scope of work for the power and the IT side of things for the actual install, and then there's us as the electrical distributor, not only providing you the Siemens AC or DC charger, but we're also looking at the power equipment and some of the commodity electricals that it's required to connect everything together. So I talked to a lot of contractors, for example, that want to get into this business. So we talk about websites, business development, marketing opportunities, different things that you can take a look at in trying to say to your clients out there that you're in the electrical vehicle charging solutions business and you're able to do that, get into that sales initiative, if you will. Just some future things that Siemens has been they're developing and currently got a lot of this in place already. Uh, as far as the Ford F-150 Lightning product, they've been working with Ford for the last 2 years, and they actually, if you buy a F-150 Lightning vehicle, electric truck from them, they can package up an 80 amp charger, which is a Siemens designed product, but under the Ford label. So it's a joint venture. They've got a lot of these reserved right now, and that's the bi-directional charger, which if you folks have seen some of the commercials where you have any power outages, you can actually use the truck to power up some of the loads within the house. On the bottom, they're actually looking at wireless charging, power charging. It's with charging pads that are put out there in the field in the parking spots. And this has to be really close coordination with the electric vehicles themselves. So until everybody comes up to speed on a different way of doing the wireless charging, especially on the vehicle side, then they'll be looking at doing some sort of wireless power charging. Um, on the right side is a real nice concept that they have coming out here probably in the summer timeframe, and that's the charging depots. And what they're doing with this idea is they actually have a single point power connection coming in overhead on the horizontal charger power busway. And then vertically are the chargers themselves. And it could be a mix of AC level twos and DC level threes based on your needs and how many chargers you need. So it's a bus arrangement that feeds power to X number of vertical chargers that are in place. So it's a faster install, lower cost, modular for future expansion, and it reduces the power wiring uh, installation, if you will. So that's definitely something coming out, here in the next couple months. A little bit of marketing and sales support. So a lot of technical reference on electric vehicles and chargers you can find under the Department of Energy. They have a section there for alternative fuels data center. And again, there's the blue link there is the link directly to it. Once you get the presentation, you can certainly click on that and get out there. And you'll find videos, you'll find a lot of the basics, you'll find incentives per state. A lot of that information is brought through the Department of Energy. We have a electric vehicle charging web page under our services and solutions drop down. So you'll have access to this link, and that gets you into again a lot of the information, the info sheet, the videos, the specs on the chargers, and out to the Siemens manufacturer websites as well. So those are two good links for you for some future reference. So that pretty much concludes our presentation. I think at this point, we're going to look through and open it up. Chris, do you want to see if there's any questions that came up and we can try to address them?
So I do not see any questions in the chat. So if anyone wants to raise their hand or just unmute and ask a question, if you have a question, go right ahead. All right, I will take that as no questions. So at this point, I'd like to thank you for attending today. If you would like more information on this topic or have additional questions, please reach out to your sales rep, or you can email us at info@sydist.com. Have a great rest of your day. Thank you.
Thank you.